Hello, and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of systems of inequalities, specifically how we can graph them and find solutions for them, and we'll do it in 5 minutes or less. So this is a system of inequalities because these two inequalities both have x and y, but they exist in the same coordinate plane. So we're going to graph them and see if we can find some x and y coordinates that might work as solutions for both. So let's start with this green one right here, and it's given to us in our standard form, ax plus by equals c. Not really going to help, so I want to solve for y. I need to get this into my slope-intercept form. I can graph it when it looks like that. So first we need to solve for y. So let's take away 2x from both sides. It's going to get me negative y is less than negative 2x plus 4. Then I'm going to multiply. You can either multiply or you can divide, doesn't matter, by negative 1, because I don't want that to be a negative y, I want it to be positive y. So that's positive y, but now watch. Remember, whenever you divide or multiply by negative, your inequality flips. So then I just distribute this out right here, so it's going to be 2x, and now it's going to be a minus 4. All right, and since it's a greater than, it's going to be a dashed line. So I know my y-intercept is negative 4 because I have slope-intercept form. My slope is 2, so I'm going to go up 2 over 1, up 2 over 1. So I'm just going to kind of plot these points right here since I know my slope. And I'm going to be able to quickly draw a line, but it's going to be a dashed line. So what I'm going to do is I'm just going to kind of connect every other dot right here. All right, now it says it is greater than. So when we're shading greater than, what we're going to do is we're going to shade anything that is above. Greater than means above. When you have a less than, you actually shade below the line. All right, so let's switch over to this red, and let's see what we're going to get with that. So the 2 is right there. I need to still solve for this y, but that 2y is sitting right there. So we're going to get 2y greater than or equal to negative x plus 2. I just need to divide both sides by 2. So y is greater than or equal to, let's call that negative 1/2 x plus 1. All right, so here's my y-intercept. And my slope is down 1 over 2. It's negative, so it's going to go down 1 over 2. So it's going to go from left to right. It's going to go down a little bit. And so what we could do is we could just kind of plot this back up. You see it's kind of a shallower slope. Now it is a greater than or equal to, so I can actually draw a solid line this time, connecting these two. And it's going to be greater than or equal to, which means we're going to shade above. All right, so when we shade above, this is what we get right here. And hopefully you notice we've got this section right here. That's where the green and the red overlap. So any solution that exists within this green and red overlap is going to work. So for example, right, we could do this. Let's do this 0, 6 right here. What that means is we can actually plug that into both different inequalities and get a true statement. So if I were to plug in 0, 6 here, it would be 6 is greater than 2 times 0 minus 4. So 6 is greater than negative 4. True. And if I were to plug it in up here, right, this y equals, or this y is greater than, I'm going to say 6 is greater than or equal to negative 1/2 times 0 plus 1. So 6 is greater than or equal to 1. That is correct. Let's see what this looks like on an actual graph. So I've plotted the original equations here. So there's my 2x minus y is less than 4. It's the green, and notice that it's a dashed line. And there's the red. So there's the x plus 2y is greater than or equal to 2. Notice it's a solid line. And so where the green and the red overlap, that's where you're going to find any solutions to these two inequalities, including that 0, 6 we found.